Here's the sequence of numbers. Here's another sequence of numbers. If you consider the y-coordinates of these points, we have another sequence here. The sequence is 7, 6, 5, 4, 3, and so on. Here's a sequence of numbers. The numbers in a sequence are referred to as terms. So we can say that the first term is 1, the second term is 8, the third term is 27, and so on. If we want to write this more formally, we can say that term 1 is 1, term 2 is 8, term 3 is 27, and so on. We can also write this sequence in the form of a table, which looks like x and y values. And we do, in fact, have an independent variable and a dependent variable. We can talk about the domain of this if we think of it as a function. The domain is all the natural numbers. The range could be written by simply listing the numbers. And if we wanted to write this with a little bit more detail, we could say n is a natural number and Tn is equal to n cubed. And so if you look back at the table, you can see that these are cubes of these numbers. Here are 3 examples of functions. We say that these functions are continuous. We say they're continuous because the points on the function don't have any gaps in them. Here are 2 examples of discrete functions. These functions are discrete because there are gaps between the points on the function. They look like functions that we're familiar with. This looks like a parabola. This looks like a straight line or a linear function. However, there are gaps between the points on the function. We haven't just plotted some of the points of the function. We're saying that these are all the points on this function and that there are gaps between them. And for that reason, we call them discrete.